Hello and welcome to this Mirantis Tech Talk titled Managing All of Your Sites with Open Source Lagoon. My name's Toby Bellwood. I'm the Lagoon Project Lead and I work for Amazy.io. I've been at Amazy.io since early 2020. A previous version of this slide said I've been here since 2000, which terrified me a little bit. But I've been here almost 4 years. But more importantly, I've been a Lagoon user and contributor before I joined Amazy.io. I worked for the Australian government in a number of teams there. And outside of work, I enjoy being outside. I live in Australia, so that's exciting and terrifying, depending on your perspective on small, creepy, crawly things. And when I'm not injured, I like doing sort of all things exercisey. I work for Amazy.io. Amazy.io is we're a team of open source and Kubernetes experts. We have what's called an open source platform as a service that we provide for engineering teams to deploy applications more easily. And we've got a number of customers, big enterprise, government, higher education, startups. Amazy.io's product is based entirely on the open source Lagoon product. So everything I talk about here for open source Lagoon is the same product that Amazy.io offers. Amazy.io offers more services on top of the open source Lagoon, but my team also works with a number of other Lagoon companies out there who provide their own services on top of their own implementations of Lagoon. So that's the open source part of it. Amazy.io is my employer, so I feel duty bound to give them a small plug. Today, I'll cover a number of things. I'll talk a little bit about what Lagoon is, how it works, why Lagoon is good for developers, and how it also benefits those non-developers. We'll talk about some use cases. I'll talk about the benefits of open source and a bit of a sneak peek onto how to find out what we're doing and what we're doing next. What is Lagoon and how does it work? I'll cover this from a couple of perspectives, from the developer perspective and from an operations perspective. But at its very essence, Lagoon is an open source application delivery platform, and it hosts application on Kubernetes. Now, open source application delivery platform is it's a fancy way of saying we've built an IDP, if you know what an internal developer platform is, but our version of this IDP is tailored specifically for web applications. It can do more than just web applications. We'll cover a little bit of that. And it's not necessarily internal because it can be hosted centrally, put in the cloud, and you can provide access to people outside of your team, or you can partition it into different teams. From a developer's perspective, what does this mean? So Lagoon is basically built on a Docker Compose premise. So these builds locally, they'll use Docker and they'll use Docker Compose on your local machine to build these applications. So any developer who's familiar with a Docker-based workflow, which at this stage is a fairly large portion of the developer universe, will be able to build their application, make sure that they get pixels perfect and they get theme flows running and they get all their interactions working just right before committing their code into Git, pushing it up to Git, and then Lagoon will take over. Lagoon's got a strong history in Drupal, WordPress, PHP, and Node apps, but it can work with almost any. I put a little asterisk by almost there because we haven't found one we can't do yet. Some work nicer than others, but it works with almost any language framework application that can be built into a Docker or Docker Compose stack. What Lagoon does is takes that Docker Compose file that you've used to build your site locally, and it translates that into Kubernetes objects. But as well as translating those Docker files and settings into Kubernetes objects, it also adds an awful lot more. So it will also wrap in the stuff you need to run a site in production. So logging, backup configuration, being able to configure your own routes, etc. All that stuff that comes on top to make your site genuinely production. Kubernetes is obviously the hotness, and we don't want our developers to have to learn how to Kubernetes. They've already got enough on their plate trying to churn out all the work they need to do and all the various languages and frameworks. Just staying on top of Node.js frameworks is more than enough work for most developers. So Kubernetes is a whole different ballgame. And then because we know developers have very specific tool sets or ways they like to develop, we like to think of people being able to use their own tool sets. So if you're used to using Laravel, for example, Laravel's got some fantastic local development tools. We're working on being able to integrate with the Laravel native local development tool and seamlessly transpose that into a production build. Likewise, Drupal and WordPress have really good local development setups. The beauty of using the same builds locally in production means that if it built locally, because we're using the same Docker file, we're using the same base images, we're using the same build steps, what you see in production should be identical to what you see locally. Obviously, you can, as some of our customers choose, you can make that not the case, but largely, if it works on your local, it works in production. So people can do thorough testing, they can do all the user acceptance stuff they need to do before they even push that Git commit. On the Git commit, you can have your own Git provider. So if you're a GitHub house or you use GitLab or you want to provision your own Git stack, Lagoon can talk to any of those Git providers, hook into their webhook system, and talk to a private Git repo hosted in any of those places. The upside of that is it can then work nicely with people's existing CI/CD setups, but we'll cover that in a second. From an operations perspective, this reliance on Docker and Docker Compose allows developers to self-start locally. So if they've got a template, if they're working on an existing project, they can just pull it down from Git to their local machine, and they should be up and running straight away. They'd be able to build their site. If they need seed databases, etc. You can get those from either a local source or you can synchronize it from the cloud. So operations don't need to provision cloud environments to get people up and running. All people need is a local machine. Very important from a security point of view is the segregation between sites, users, etc. So every single project being a website in Lagoon parlance, every single project can have different environments. So a production environment to host your production site, but all of your development, branch, pull request, each one of those workloads is separated inside your Kubernetes cluster. So you've got network policies that stop people from being able to view outside their own project. But importantly, if you want to synchronize your production database to a pull request branch because you're doing some kind of testing or you're doing some kind of integration work, those environments are allowed to talk to each other. So you can synchronize databases and files between environments. And all of your users have full RBAC. So you can set role-based access control for developers or maintainers. You can give them access to be able to modify production environments. You can disable who can push a database to production, for example. So only your developer leadership team can push databases into production and potentially break things. So it allows you to set up your team how works best for you. The Git-based workflow drives a development environment creation. So rather than someone wanting a new dev environment to do their QA or to do their acceptance testing on, all they have to do is create the new branch in Git, and Lagoon will see that a new branch has been created as long as it meets your stipulated criteria for what branches to develop. I'll cover that a little bit in a second. As long as it meets those criteria, Lagoon will automatically provision that environment for your developer or for your team. So you don't need to worry about scheduling it into an operations team to get a new environment provisioned and waiting. It just happens automatically. From an operations point of view, you can manage cluster-wide configuration. So the logging metrics and backups that we've talked about being automatically added to those projects, you can configure where those logs go, what metrics are collected, what backup schedules you are, what retention periods you have. But most application-specific configuration is managed by the developer in their Docker Compose files. So as an operations team, you don't need advanced knowledge of what the application is. You just need to know that Lagoon will translate this application into Kubernetes objects, and you can view them. You can use Lens or whatever tool you want to be able to see that application running as a normal Kubernetes workload, so deployment, stateful sets, replica sets, ingresses in production. One of the biggest features of Lagoon is it works to automate managed database provisioning. So these kind of applications, CMS, LMS, web app type things, they're very database centric unless you're doing static site, progressive web app type stuff. This database provisioning is the hard part of web apps. So Lagoon uses a database as a service tool, and that can read your Docker Compose file. It can see that this application requires a Postgres database. Lagoon can translate that requirement for a Postgres database from a container to provisioning a database in a managed database cluster. So if you're in cloud and you've got RDS or Google Cloud SQL or Azure SQL, you can provision a database cluster in Lagoon, and then Lagoon can manage the deployment of databases to that cluster. So when you provision a new environment, Lagoon will automatically create a new database as required. If your application needs 2 databases, it will provision 2 databases automatically inside that cluster. If you've got advanced needs, if you've got a separate production and development database cluster, we can do that. We can provision as required on whichever of those, but that happens automatically. So again, you don't need to wait for someone to set credentials. Those credentials just get generated automatically by Lagoon and put straight into Kubernetes, and the Lagoon, the application provisioned by Lagoon, knows how to talk straight to that database. And we work with all Kubernetes distributions and cloud providers. So in cloud space, obviously the main ones, Google, AWS, and Azure. But we've also been working with a number of customers using other providers. There are demonstrations using the full suite of Mirantis Kubernetes platforms, so the managed OpenStack Kubernetes, the K0s, etc. And because we want to try and really visualize what Lagoon does, getting all those applications to work on Kubernetes is a relatively painful exercise. And we're trying to put Lagoon in the middle and make it a little bit easier rather than having to do all that stuff yourself. My team spends a lot of time on the relevant application forums. Most of them have a Slack or a Discord, and most of them have a channel called hosting, and a lot of them have real difficulty trying to get their applications to work on Kubernetes. So we're trying to take some of the complexity out of that. Lagoon itself has 2 main components. There's a Lagoon core, and there's a Lagoon remote. One Lagoon core can power multiple Lagoon remotes. A Lagoon remote can only talk to one Lagoon core. So the Lagoon core lives centrally, and that hosts the API components, the authorization components, and a lot of the sort of backup handlers, action handlers, webhook handlers, those sort of things, that sort of central command and control spot. The API is built in Apollo GraphQL. We use Keycloak for authorization. We use OpenSearch or OpenDistro for logs and log management. And there's also the UI and the webhook stuff. So that's all the components that sort of talk to the outside world from a Lagoon point of view live in core. Core doesn't host client workloads, and core, for this reason, has a very predictable sizing. So you can provision a cluster of 2 or 3 nodes, and you can power a Lagoon core. It is possible to deploy a Lagoon remote and Lagoon core into the same Kubernetes clusters, and a lot of the smaller install bases do just that thing. But for a large customer, Amazee.io is an example, we host a number of Lagoon cores, but each Lagoon core will power, in our largest case, upwards of 30 remotes. So these remotes, they can either be dedicated to a particular customer, they can dedicated to a particular client, a particular workload type. So you can have a development only cluster, an only development environment to get provisioned to that. You can have a production only, likewise. You could have a pull request cluster that only deploys pull requests. Lagoon's got some real smarts in there as well to handle idling. So if you've got a web application and you're doing user acceptance testing, you can push your Git branch and it will create a website for you to user acceptance test. Once you've finished your user acceptance testing, that website isn't needed. You might need to do more testing, so you don't want to delete it. So Lagoon has some real smarts in there around idling, so it can spin the Kubernetes components down, and it can use Kubernetes scaling properties to scale down to sort of 0 pods. If someone else hits that URL, they'll get a small holding screen, but in the background, Lagoon will go through and it will unidle that application for you. In the remote space, that's where all the client workloads live. So that's where all these applications and project namespaces are actually deployed. And again, these remotes can be anywhere, they can be any size. But inside these remotes, this is where the database operator lives. It's where the backups happen. It's where our image registries, because obviously everything's built on Docker images, the image registries live in remotes. And the log collection is all done there. So there's two different workloads, two different kinds of application, or two different kinds of workload that run in these different clusters. And that's why normally we'd recommend to separate them so you can have a predictably sized core and you can have a fluctuating size remote. A quick overview of how Lagoon works. So developers push code into their Git repo. The Git server sends a webhook through to Lagoon core. That Lagoon core knows where that workload either currently lives or should live if it's a new branch. And that respective Lagoon remote will start the deployment. And from that point onwards, the only connection between remote and core is that core will hear from remote when that build is processing, and remote will send a couple of logs back to core to say that the workload is up and running. But the workload now lives completely in remote. Core's done its job in terms of triggering that deployment. Now it sits back and waits for its next task. This really removes the need for developers to know about the Kubernetes. If they've done their Git push, they get a little message in the UI later saying, hey, your site's up and running, visit this URL. And anybody that's used any kind of these application deployment platforms, they know this workflow is quite familiar to them. So why should developers use Lagoon? Why do developers prefer Lagoon? I can't say it enough times. Having to avoid developers knowing about Kubernetes is a really big thing. I knew nothing about Kubernetes before I started working with Lagoon, and I had a choice. I had to avoid Kubernetes completely and keep doing my thing, or lean into the Kubernetes side of things. And 6-7 years later, I'm glad I did, but it's a steep learning curve. The build and deploy system, this streamlines everything from those test environment creations through to those managing those deployments for you. Lagoon can be integrated into existing CI/CD workflows and processes using your own Git provider. So if you're a heavy user of GitHub Actions or GitLab CI, you can build a CI process. And again, because we're talking about Docker Compose, you can actually do an awful lot of test processes inside that CI. So you can stand your web app up in CI using Docker Compose, and you can do a visual regression test, or you can do cucumber gherkin tests on it. You could run Cypress testing inside your CI. That process can run through in your CI. It can give you the feedback immediately. And if it passes all your CI, you can have a final CI step that triggers your deployment in Lagoon for you, goes off and puts it up. You can do it the other way around. You can trigger into Lagoon and you can run CI processes there. There's a fully customizable task system that allows you to do pre and post rollout tasks that you can do to make sure that your deployment's actually done what you expected. To help this out, we've got a full user interface and a full CLI that can be used in these workflows. We've also got GraphQL APIs, so people that are braver, bolder, want to be slightly closer to the matrix can use GraphQL to do their kind of customization, control, and configuration work. The whole idea is that this Lagoon can be managed by operations experts. It's just generating Kubernetes objects. So things like high availability pod disruption budgets, HPAs, they can all be configured by Lagoon and by the operations team. This means that your developers don't need to worry about that, how to set scaling parameters, and they can just focus on building the apps. Apparently, according to a couple of surveys, developers spend less than 50% of their time actually coding. Apparently, they spend a lot of time waiting for infrastructure availability, operations, security, meetings, other stuff, learning. Debugging is a really important one, and we'll cover that briefly in the next slide. But we want to be able to have developers doing their development as often as they can, because we think that's really important. That's where their skills and their time is best spent. So reiterating, tooling, developers can use whatever tools they work locally. We do have people who still use MAMP or LAMP stacks locally and then push their code, and they've got the Lagoon scaffolding set in their repository. So it will automatically transfer their LAMP settings into Docker. We grimace slightly whenever people do that, but that's their wish. That's the way they work. Visibility, so easy access to being able to see the build, see the applications running through, access to the logs. Lagoon also supports integration at the application level with tracing, so New Relic, Blackfire, and debugging. So if you're a PHP person, Xdebug is pretty much the gold standard. These tools integrate with Lagoon locally, so you can stand up your Docker Compose, do your debugging, but also in production, you can connect New Relic accounts and you can connect Blackfire accounts, and you can see exactly what's happening with your application and monitor your app for any slowdowns or bottlenecks. The Git-based configuration makes it really easy to reproduce. So you can deploy the same branch in two places. You just need to Git fork to create a new branch, and you can then deploy that somewhere else, and you can compare those two environments. You can make those small changes. You can see what's happening in Git. When Git isn't quite enough, Lagoon does allow you to do simple variable-driven customization. So if you need a recapture key available in production so that you can use recapture to find out how many people can tell the difference between a bicycle and a traffic light, you can pass those kind of variables into Lagoon, and Lagoon will handle them in that system. You can isolate those secrets to particular environments. You can set them at the project level, etc. The economy of scale, basically using this same scaffold, using the same Lagoon configuration, you can deploy a Drupal site, a WordPress site, a Node.js. You can deploy a Django-based learning management system. They all use the same underlying concepts. They all use the same labels in Docker Compose files. They all have the same standard config file. So rather than having disparate tools, one tool to do your Node apps, one tool to do your Python, one tool to do your PHP apps, you can use one tool to do them all. So that real economy of scale, once you've learned how to Lagoon something, you can Lagoon everything. That's our goal anyway. And yeah, the scriptable CLI and GraphQL tooling. So CI/CD and workflows can be really easily automated. I've got a couple of quick visuals of what Lagoon is, what it looks like. So here I can see a list of all the projects that my user, owner at example.com, not a real person, has access to. A range of projects in here. There's a React example. There's a couple of Drupal examples. There's also an application called Lagoon UI, which is Lagoon's UI, which runs inside Lagoon, so it can take advantage of, as we're developing pull requests, branches, etc. So a developer can see their projects that they have access to in this. The full list of projects is thousands, but this developer only has access to 13 projects at various permission levels. If I'm digging down into one of those projects, this Drupal seed project, we can see a quick overview. You can see sort of a snippet of information, when it was created, where it lives, how many of my development environments I have. So I have a number of environments. And there's a lot of information on the screen, but you can see here we've got each of these environments has a cluster and a region set up. So inside the Lagoon configuration, we've configured this project to deploy to 3 separate clusters, which are called Test 6, Test 1, and Test 9. And they live on 3 different cloud regions. one for each of the major providers. And our project is deployed. If we push anything to the test 6 branch, that will deploy the test 6 environment. If we push to test 1 or test 9 branch, it will push to those environments. Got a couple of other ones as well. So we've set up a way to make sure that anything with the cluster name goes to that specific cluster. So a test 1 branch goes to test 1, a test 6 goes to test 6. But you can see in this screen which environments are running, and you can click on the routes and go and visit that site directly from the user interface. A couple of other pages which won't go too deeply into here, but this allows you to configure those variables at that project level. So yeah, keys, secrets. It could be that you just need a couple of variables that you might need to change from time to time without having to do a git push. When you do a variable change in Lagoon, you may have to do a redeployment to make that variable work throughout your application. So you need to, you can pick a scope. You can do a build with a variable. So if you've got a Docker file that uses args and envs, you can pull that variable through your build without having to push to git. You just trigger a build again inside Lagoon. So from a non-developer point of view, how do the rest of us that aren't hardcore web devs, what's in Lagoon for us? So Lagoon's got a full suite of tools called Insights that I'll cover in detail here. And it's got some really nice functionality around managing organizations and groups. And I'll cover that as well. It does have this multi-cloud physical cluster separation, which in modern days is really important from a data sovereignty point of view, from a workload isolation point of view. So being able to spread your workload across multiple providers, it could be that if you're looking to host a Lagoon yourself for your own applications, you only deploy to Google or to AWS. But if you're providing a Lagoon service to others, like Amaziah.io does, or a number of our users do, it's really important to be able to provision into the right provider. Nowadays, with the ubiquity of almost every country that has one vendor has all the vendors. But a couple of years ago, it was the case that if you wanted to provision into a specific country, it may be that there's only one vendor that has a cloud there. So from a data sovereignty point of view, you'd have to go with Google, you'd have to go with AWS, or you'd have to go with an on-prem solution if there was no cloud available. That's why multi-cloud is really important for us. Physical cluster separation, I've spoken about separating production and development workloads. That, in conjunction with the idling, means you can set idling parameters on that. You can set more aggressive idling parameters on that development cluster, because those development environments aren't going to be around as long as those permanent production environments. You can use spot workloads if you're in hyperscaler land. And that way you can sort of aggressively scale down your clusters at the end of the working day. If you've got them geographically located, the working day is only a quarter of the week. So you need your cluster running at full capacity for developers during the working week. At the weekend, when there's going to be 2 or 3 people trying to do last minute code pushes, it will still come back up and it will still spin and rescale, but your baseline is much lower. There could be need to physically separate clusters for specific customers. A customer, in Amaziah.io's case, customers can purchase dedicated cluster access. So we'll provision a cluster specifically for them. So their builds, their applications, they all live only on their cluster and no one else can deploy projects to it. Limiting the system spread, having it all managed by one provider is it makes it much easier from a management point of view. It makes it much easier from an access control point of view. So rather than having multiple applications in multiple places and having to work out how to manage these apps here and those apps there, having it all managed through one central place is a real benefit. So Insights tools. So Insights is a suite of tools that we've built in the last couple of years that are intended to help teams understand their applications and to meet security and supply chain obligations. So to understand your applications, we're talking about the versions of software in use, applications, Because this can differ greatly between environments, you can be testing out a new version of Python in your dev branch. You could be testing out a different version of your application. You're able to see and visualize that through these insights tools. And from a security and supply chain obligation point of view, having ready access to things like SBOMs, software bill of materials, and vulnerability scans gives you immediate insight into how current or how up to date your applications are. When a build or a deployment runs in Lagoon, Lagoon can also trigger what's called an insights run. And in this case, this is a Drupal application. The insights run has scanned there's 3 main container images there, the CLI, the Nginx, and the PHP. And the insights run has done 2 different kinds of scans on that. It's done an image scan and it's done an SBOM scan. This gives it all the information it needs to be able to do that kind of application and version collection. Those files are also available to download. So if you want to download the SBOM straight from Lagoon, you can, and you can then run that through a vulnerability checker. Because it's a standard SBOM format, it can run with any of the SBOM, any of the vulnerability scanners. You can just provide this file to them for reading. You don't need to generate one of these files on demand, because your application, as deployed, at the point it was deployed, your application won't change in between deployments because it's Kubernetes, because it's Git triggered. Whatever was deployed in that deployment is what is run until the next deployment. So that file will remain current until your next deployment. So rather than regenerating one of these SBOMs on demand, we save the SBOM at deployment. So if someone asks you, what vulnerabilities have we got? You've got 2 options. You can either download that application package for that specific application, or there's functionality inside Lagoon that can run those scans as well. Inside any given environment, you can see the versions that are running. So this is an old version of Drupal 10.1 running on PHP 8.2 on an Alpine 318 image, but it's built using the 24.2 release of Lagoon images. So there's a lot of information there that can help a user who isn't technical know what version of Drupal will be running, or what version of PHP, or if they get an alert saying there's a CVE that impacts Drupal version 10.1.2, without having to ask a developer, anybody in the team with access to Lagoon can see, oh yeah, I can see that our test 6 environment is running Drupal 10.1.2. We're going to have to address that. Previously, they'd have to ask a developer, send a DM, or go and hover over their shoulder to say, hey, what version Drupal are we using? This way, people can see that kind of information through the user interface without needing to ask someone else to get that information for them. The next phase of insights will allow you to be able to search through all of your environments for this specific information. So at a glance, someone should be able to say, tell me what Drupal version all of my sites are running. So you can go through and you can say, okay, there's only 3 that we actually need to upgrade. Which version of PHP are we running if PHP is becoming end of life? What version of Node? And that will allow people to specifically target and to build programs around the versions that are in place. Lagoon does have vulnerability scanning in place. So here we've used Trivy and Gripe, 2 vulnerability scanners, to assess this particular site for some for vulnerabilities. So we can see there's a couple of issues here with a JWT library. There's a PSR vulnerability. I can see those at a glance. And again, we're building tooling that can aggregate that up. So if I was looking for that particular CVE 2020 26160, I can search that and I can see that across all of my environments. So I can see which of those environments are impacted by that particular CVE, and I can build my remedial action plan based on the facts of those environments. Organizations is the other key plank to enterprise web application management. So being able to fine-grain manage groups and roles, manage projects and project life cycles, and being able to set quotas for users are something that we've built into this organization functionality. So for a given organization, you can configure an organization to have groups, projects, notifications, etc. So you can set up a number of groups to suit your development work team. So if you've got an alpha team and a beta team, if you've got a day shift, night shift, if you've got an in-house dev team and an external contracted dev team, they can be given individual groups, and those groups can be given access to projects. You can have multiple projects under an organization. So in a situation where you're deploying one Lagoon and one remote, and it's only for you, this may be more useful for just managing users. But in a situation like Amazio or like someone hosting Lagoon for external use, being able to provision each customer with their own organization, and those organizations can then manage their own projects. All they can see is their projects. We can set quotas and limits on that. So you could set up as many groups as the quota system allows. You can set up projects. So if your customer's only paying you for 5 projects, you give them a 5 project quota. If your customer's paying you for infinite projects, congratulations. They can then keep creating their projects themselves up to their limit. Inside this organization, you can manage your group. So this demo group has a couple of users who both have maintainer permission, and there's one project that people in this group can access. So either the maintainer and the org user, those users can both use Lagoon to access the Lagoon demo org project. They may be able to see other projects because they may be members in other groups that can see other projects. But if I wanted to stop my maintainer user from being able to access Lagoon demo org, all I need to do is unlink them from that project, unlink them from this group, and they suddenly lose access to that project. An individual user, so we can see this org user has access to 2 groups. So we can see they're in the demo organization group as a maintainer, and they're in the demo organization group 2 as a developer. So going back to the role-based access control, the maintainer user can access to production environments of that organization, any project that's in that organization group. The developer user can only do certain things in production. So maybe org user is just a bystander for any project that's in group 2, but they're an actual lead dev in anything that's in group 1. If they need to do more, we can change their role quite easily inside any given group. And this is all managed here. You don't need to worry about GraphQL or CLI commands. The person that's managing and administering the dev teams can do all that inside the UI. So we spoke a little bit about multi-region, multi-cluster, multi-cloud, separating your workloads between production development, dedicated for customers. We can isolate. We do have one customer who refers to one of their clusters as a naughty corner. That's where projects that are potentially misbehaving can be deployed to, I think, make their level of comfort with those applications. It doesn't mean anything. It's just funny when projects get deployed to naughty corners. The secure access for those workload separations. So providing access only to those individual clusters in a situation where Lagoon is being deployed into a cluster that your customer also has read Kubernetes access to. You can manage access quite securely that way. And being able to provision a new cluster inside Terraform or whatever OpenTofu tool you use these days, that can be quite quickly provisioned and connected up to Lagoon, and workflows can start running through. Using multiple regions can be important from a data sovereignty point of view, from a latency point of view. Speaking firsthand, based in Australia, trying to do anything that requires command line access to tooling that runs in Europe can be slow. But if my project can be deployed to a cluster that's geographically close to me, my development experience is just better. And also from a disaster recovery point of view, you can simultaneously deploy the same branch to 2 separate clusters on 2 separate providers on 2 separate regions. You can mirror effectively, you can deploy your project in 2 places, and you can synchronize databases between them. So you've got a full disaster recovery situation there. And yeah, working on any Kubernetes, so any of the hyperscalers work nicely. There's a couple of requirements we have. They're mostly boring things around the ability of storage classes and access to databases and the configuration of ingresses, but we've got documentation on that. But we have some on-premises options as well. We've got customers using all of those as well, talking to the same Lagoon core as all the other providers. And we can see here that test 1, test 9, test 6 configuration. My project is set up to deploy any branch called test 1 goes to test 1 cluster. Any branch called test 9 goes to test 9 cluster. Everything else goes to test 6. So in this situation, test 6 is my main cluster. So if I built a dev branch, that will go to test 6. And because Lagoon is able to build pull requests, we can also deploy pull requests. So any pull request that comes through will get deployed automatically to that test 6 cluster as well. So we can configure those individual projects to deploy exactly how we want to. I'll talk through a few use cases. So our customers do something called base image builds, and this is where they build a Docker file, a Docker image that contains the base of their application. So it could be they've got pre-approved modules for Drupal, for PHP, for Node, for Python. That's automatically built into one single image that's then centrally maintained, that the team can then publish on a weekly, monthly, quarterly basis. The development teams then consume that image to build their application on top of. So rather than the Docker build having to build everything from scratch, it's starting half or 2/3 of the way. It's got the application, it's got all the language and the language dependencies. All it needs to do is put the application configuration on top. And that can really speed up builds because you're not having to do as much heavy lifting. You can have your base image build everything apart from a /themes folder. If you're in a CMS land, the entire CMS is built as base image, and you just put your theme on top of it. We've got something called polysites, and that's where you can use one single Git repository to provision multiple different websites. So if you've got a whole family of sites that use an identical code base, but might be configurable with a variable, so you might have a color scheme, or you might have your configuration may be stored in a database, you can use a polysite. And that basically means when you push a Git commit up to the Git repo, that will trigger a webhook to deploy every environment that's built from that same Git branch. So if you've got 20 sites that are all exactly the same apart from their content, you can use a polysite to trigger that. And that will trigger every one of those 20 sites will deploy at the same time, and they'll grab whatever new images come through the build, and they'll add their specific configuration from their databases or from their variables on top of that. To manage those, we have the concept of bulk deployments and quality of service. So for people that do like to trigger 1, 10, 20, 50, 100, 500 deployments at once, we've got tools and mechanisms in place that can make sure that those builds go through in an orderly manner. You can set priorities and quality of service so that a production build will never get stuck behind a development build. You can do a maximum number of concurrent builds, etc. Decoupled websites are really popular with our customers, and that's where you provide a CMS backend, CMS type backend. So it could be Drupal, it could be one of the other static sites. Strapi is a really popular one. And they basically provide an API or an endpoint, and then you build a front end in Node, Next, or something that talks that back end. And you can either deploy that as one project or as 2 separate projects and have separate development cadences for the back end and for the front end. We can use those insights and Lagoon's task system to manage organizational policies. So if you've got strict needs around Drupal versions or PHP versions or file system sizes, you can write tools that you can then generate tasks to run in environments that can run, check and inspect those environments, and they can report back. So we've got a couple of customers doing some really advanced stuff there. And we work with a number of people who've built entire SaaS platforms off the back of Lagoon. So Lagoon provides the infrastructure, and they've written their applications as a SaaS platform. So they can just, when a new customer signs up, they do the Git clone, it provisions a new environment, and that customer then gets access to the application running on Lagoon, but it doesn't necessarily get access to Lagoon. So the team that's running the SaaS platform can manage all of their applications inside Lagoon. The users and their customers all access the web apps directly through the web interfaces. Open source. Why is open source important to us? Lagoon is 100% open source. Our code's all available on GitHub, github.com/use-lagoon. I'll put the link up in a bit. But it's really important for us to be open source. And we believe that code transparency is the number one place that we've seen the benefits. We've all used SaaS or PaaS applications in the past, and we've tried to figure out how something works, how something fits together, why it does what it does. Code transparency allows our users and our customers to be able to see exactly what's happening. They might not be able to physically change it, but if you can read Go or Node, or you can decipher thousands of lines of bash code, you can see what's happening in Lagoon behind the scenes. So you can see why it's made the decisions it's made, why it's operating the way it is. This is also really cool from an engaged user point of view. And the engaged user, the advanced user, is some of our customers have large developer teams, and these are all really, really smart people. They're able to directly contribute towards fixing and resolving issues. So nothing gives me a greater thrill than seeing an issue or even a pull request come through from someone saying, hey, we had this issue today. I did some debugging and I found out it's because someone made a typo in a variable name, or because there's a code loop that you hit on a particular combination that just infinitely recurses. Having those kind of things picked up by our users is brilliant, because we can't think of every single use case. And anybody that digs deep enough into our code will see all the exceptions we've had to put in place just to deal with those use cases that come up from time to time. So those advanced users, they can really dig in and they can really feel a level of investment with the application they've chosen to build on. Easy customization. So if somebody wants to, we've got a couple of Lagoon users out there who want some new functionality in the way that Lagoon handles ingresses and routes. It's not something that my team's entirely convinced of yet. So these people are going out and they're using a fork of our build deploy tool to build that proof of concept to show that what they're doing works. And they can do that level of customization because they can fork the repo and they can consume that build tool for their builds. So they can do their demonstrations without having to stand up the entire application from scratch, without having to get elbows deep in building an entire platform. They can customize the specific bit that they need to show that what they're doing works. They can then choose to contribute this back. We ultimately have to decide whether this is a greater good thing or a limited impact thing. But from a contribution point of view, we really, really value those contributions from our customers. So where we've got people who are making suggestions, whether it's a simple, hey, it would be really cool if Lagoon did this, to picking up mistakes or errors, to contributing docs, to asking advanced use cases, that every bit of contribution helps us set that direction that we're going. So if we see a lot of people asking for something specific, well, if 10 people have bothered to hit up GitHub and comment on an issue that this would be really valuable, this must be really valuable. We don't need to ask people if it is. We know it is because they've told us. Being able to debug those issues as well is really crucial for those more advanced users. I'd classify myself as a power SaaS user. If there's a SaaS platform, I'll work out the way of using it to its full extent. Having access to that code makes it really easy to be able to see exactly what's going on and pick up exactly how it works. My first contributions to Lagoon were before I joined Amaze.io, and we've got a number of users, a number of team members that are in the same situation. So we've only got a few minutes left. Sneak peek on what we're doing next. New look user interface. So all those screens that I've just posted, we'll be changing those in the next few months. And we've built this one from the ground up to have UI components, so we can then provide a similar look and feel across potentially different plugins. So we want to start looking at a plugin for Lens, so that people that are managing a Lagoon have got a Lagoon interface that plugs into Lens. People that use Docker Desktop locally, so developers, they've got a special tailored user interface that they can use to interact with their builds inside Docker. And having a UI component library makes it much easier to build all of those various things. Build and deploy system is always evolving, trying to get builds faster, trying to get things smoother as we move more and more into Node and JavaScript apps. Deployment is key, deployment speed is key, so trying to get that build speed up faster. General performance improvements. We've got a big sort of 2 quarters of work here, getting a lot of the performance, working really hard on how smoothly Lagoon works. It's been an open source project for 7 years, so there's some 7-year-old code in there that we're trying to reevaluate. Is it still fit for purpose? If you want to find more about what we're doing, github.com/use-lagoon is the best place. That's got a full about us. That's got links to our Discord chat communities. It's got our blog where we regularly post articles about what we're working on, what we're releasing. Coming soon, we'll be restarting our office hours. So we hold monthly catch-ups for customers, users, contributors, where the members of my team will make ourselves open to questions, debugging, a little bit of development insight, etc., and also access to all of our social stuff. So quick plug from AZIO. We're always hiring somewhere in the world, specifically in the US time zone. We're looking for a couple of positions at the moment: technical marketing, content writer, and a product manager. Visit us at AZIO/careers. And likewise, keep an eye on the Mirantis careers pages as well to find out what's going on in that space. Keep an eye out for the next webinar coming up. We've got UC and Julian talking about day 2 operations with K0s, Cosmotron, and Cappy. To wrap up, thanks very much for coming, for listening, letting me talk at you about Lagoon for the last 55 minutes. I can be found on all those various things. Luckily, I have a pretty unique name, so I'm not that hard to track down. Also figured that Lagoon is a featured presenter of sorts, so you can find a bit more about Lagoon there at the various social links. So thank you very much for having me. It's been a pleasure talking about Lagoon. Hit up the Use Lagoon page, find out how to contact us, or ping me directly. I'm more than happy to take questions, to try and find out more about what you're doing, why you're looking at Lagoon, and where this will all come in handy.